G'day and welcome to the fifth video on calculus. This video we'll be looking at the chain rule, which is exercise 5.4 in your textbooks. This is particularly helpful. The chain rule, I think you'll use the chain rule in almost every calculus question, to be honest. Like there are very few times where you don't use it. And they love to play on the chain rule quite a lot as well. So it's very useful when you have a function inside of another function. Okay, for example, let's have a look at this one here. Y equals the outer function is the whole thing cubed. The inner function is x squared minus 2. So for example, you've got x cubed as the outside function, and the inside function is x squared minus 2. Okay, you don't need to know too much about that, but that's just where it's very useful. So you've got an outside function and an inside function. Now what you could do is you could just expand this function here, and then get all the like terms together, and then have them all singularly. So you'll have like a x to the power of 6 term and the x to the power of 5 term, and yada 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 yada, all the way along. But who can be bothered doing all of that, particularly when the numbers are so high? So instead, what we're going to do is going to use the chain rule. Now the chain rule relies on us inserting another variable. So for example, I'm going to say that u equals, I don't know why we use u, it's just most textbooks and most people who do maths use u. I'm going to find out why we use u another day. So u is the middle bit, so u equals x squared minus 2, and the outer bit is I guess just going to become u cubed. And then what we're going to do is we're going to get the derivative of these two things separately. Okay, we're going to find du dx, which is 2x, just from this one, and then dy du, which is 3u squared. And then what we're going to do is we're actually going to say that the original derivative from this one, say dy dx, because that's what we're actually trying to find, dy dx can actually just be a product of du dx, which is this one here, and dy du, which is this one over here. Notice how the du's will cancel out from each other. So you just get dy dx equals du dx multiplied by dy du. And what ends up happening is we get 2x multiplied by 3u squared, which again, if you put the u back in, it becomes x squared minus 2. So it's 6x multiplied by x squared minus 2 all squared. Okay, and I wouldn't bother expanding that. I wouldn't bother doing anything else about that. I'll just leave it as it is. Sometimes in exam ones in particular, people do too much work. They try and simplify, they try and do a whole lot of things. You've got to look very carefully at the marks allocation, because in this question, it's probably only going to be worth 2 marks. A mark for using the chain rule, which we have, and a mark for the answer. And it doesn't need to be simplified or anything else. Okay, but anyway, the point of this was to get you to see that the chain rule actually works. Let's just do this on the calculator just to see what the calculator might give us. So what am I doing? I am doing the derivative, which remember is shift minus with respect to x, and I've got x squared minus 2 all to the power of 3, and that was my answer, which is exactly what I had. Okay, so it does actually work. It works very nicely. So another example that I've got is this one here. The square root of 2x minus 3. That can become the 2x minus 3 all to the power of a half. Now, unlike the first one, we can't expand this. We don't know how to expand something to the power of a half. The first one, we could have done something about that, but there's no way that you can expand this one here without many complications. So what I would do is use the chain rule for this. I would say that u equals the middle bit, which is 2x minus 3. And therefore the outside bit is just going to be u to the power of a half. Okay, and so when I get the du dx, that's just 2, and then dy du, this one multiplied by everything by a half minus 1 from the power, so I get half u to the negative a half. And then I need to put dy dx equals du dx multiplied by dy du, and I get 2 multiplied by a half u to the negative a half, which turns out to be 1 on the square root of 2x minus 3. Because the 2 and the half cancel out each other, and then u to the negative a half, well, I just put the power on the bottom. So I guess it should have been u to the power of negative a half, which is, what is it? So that's 2x minus 3 to the power of negative a half. But rather than rather than doing it negative a half, I dropped the sign down to the bottom, made it positive, and there away I went. Okay, so if you want to summarize the chain rule, I guess you can use dy dx equals du dx over dy du. Or another way, using words that I've found helpful, is to say that it's the diff of the inside multiplied by the diff of the outside. The inside isn't changed, but the outside, I guess you do have to minus one, multiply everything by the power and then minus one from the power on that. Hopefully that makes a little bit of sense. If you have any more troubles, just send me an email. Otherwise, you can check your textbook for a couple of more examples as well. So thanks very much.